Hello students, let us study about dioxygen or O2. So first of all, let's see the preparation methods, how oxygen is prepared in the laboratory. So the laboratory preparations are, first one is from potassium chlorate KClO3. So KClO3 is potassium chlorate. On heating potassium chlorate in presence of MnO2, it produces KCl and oxygen. So this is the first method. Then second method is heating oxides of metal low in the reactivity series. So silver, lead, mercury, they are low reactive. So the oxides of those metals can be used for the preparation of oxygen. So on heating these oxides, Ag2O, Pb3O4, PbO2, HgO. So these oxides can be used for the preparation of oxygen. So on heating these oxides, we will get oxygen. So in the first and last case, that is silver oxide and mercuric oxide, the metal itself is the byproduct, and in the case of lead, it will be lead oxide. So PbO will be the byproduct in these two cases. Next, third method is from hydrogen peroxide. H2O2 is hydrogen peroxide. On decomposition of hydrogen peroxide in presence of MnO2, H2O and oxygen are formed. So these are the three laboratory methods for the preparation of oxygen. So I have not balanced this equation. You have to balance this equation. Then another method is large scale method, large scale preparation method, that is actually the electrolysis of water. Electrolysis of water, H2O, electricity. So H2 and O2 are formed. Here we know hydrogen and oxygen are formed. H2 will be formed at the cathode and oxygen O2 will be liberated at the anode. So by the electrolysis of water, we can produce oxygen. So that oxygen will be produced at the anode. This is actually a large scale method for the preparation of oxygen. Now let us see the properties. So oxygen is a colorless, odorless gas. Oxygen is a colorless, odorless gas. So it is highly soluble in water. It is soluble in water. That is why it supports marine or aquatic life. So we know oxygen is highly soluble in water. So that dissolved oxygen will be used by the aquatic species. So we can say that supports marine or aquatic life because of this property, that is, which is soluble in water. Then another point is oxygen is paramagnetic in nature. It is paramagnetic. So it is attracted by the magnet because of the presence of unpaired electrons. So unpaired electrons, due to the presence of unpaired electrons, it will be attracted by the magnet. So we can say oxygen is paramagnetic. Then oxygen has three stable isotopes. Three stable isotopes. They are O16, O17 and O18. So three stable isotopes are possible in the case of oxygen. They are O16, 17 and 18. Now let us see the reaction with metals and non-metals. So almost all metals, nearly all metals and non-metals react with oxygen to produce their corresponding oxides. So metals and non-metals react with oxygen to produce the corresponding oxides. But some metals like gold or platinum, that will not react with oxygen. So dioxygen will not directly react with gold or platinum. But in all the other cases, all the other metals and non-metals will form the corresponding oxides. Let us see some examples. In the case of sodium, calcium, aluminium, then these are examples of metals. Then P4, phosphorus is a non-metal. Then carbon is a non-metal. Some compounds like methane and zinc sulfide. So these are some compounds. So metals, these are examples of non-metals. These are examples of compounds. So in all these cases we can see the oxide formation. So in this case Na2O, sodium oxide is formed. Here it is calcium oxide. Here it is aluminium oxide. In this case it will be P4O10. Then here it is CO2. Here it is carbon dioxide and water. Here it is zinc oxide and sulfur dioxide. So these are the oxides formed in the case of different metals, non-metals and compounds. In all these cases, oxides will be formed. Okay, these are the examples. Here we can see the oxides with metals, non-metals and some compounds. So I have not balanced this equation. You have to balance all these equations. Now let us see the uses. There are different uses. Important uses are, actually it is very important for respiration and combustion reactions. Then it is used in oxyacetylene flame, and it is used for the manufacture of different metals. Then it is used in oxygen cylinders. So there are different uses. So these are important uses of oxygen. So this is about dioxygen.